Hi, I'm Francesco Campoi and this is Just for Funk. Welcome to episode number 39 of Just for Funk. Today we're going to be reviewing and refactoring some new source code. Now, who's the author of this beautiful piece of code? Well, it's me.
Mario!
What we're gonna do is we're gonna be reviewing and refactoring the code that I wrote for the previous episode, episode 38, and we're gonna make it better so we can then reuse it later on episode 40. Episode 38 and episode 40 are part of Go machine learning for Gophers, but not this one. This one is just like refactoring, and there's a lot of things that are pretty wrong, so I think it's gonna be an interesting episode. Does that sound fun? Let's get started. Okay, so what I did was simply move everything that I had on episode 38 to episode 39 and just copy everything there. And if you remember correctly, so if we do go build of this, and I'm gonna call it main, when you run it, it just runs for a little bit, not too long, and then it generates this graph here. That is what we wrote previously. If you don't know how this works, refer to the previous episodes, which will be linked here. There was one on where we showed how to do the plotting, and another one where we computed how to compute that line. Now, today, we're not gonna change anything of the code, changing the behavior of it. What we're gonna change is its maintainability and trying to make it a little bit better. Okay, so let's get started. Let's see what the code does. So it declares this variable iterations, which has a default of 1000. Then it parses the flags, reads some data that returns a plotter.xys, and then it passes that to plot data. Also, it does this thing here. There's no good reason for this other than probably I forgot to remove it. So let's start with that. Let's just remove that one. So then we have this XY struct, which is interesting because I'm not sure whether we use it anywhere. It doesn't look like it. Do we use it anywhere? So if I delete it, no one complains, and go build still works, go install. Okay, so that was a completely unused type, so it's good that we removed it. As you can see, I wrote this code without paying that much attention. Read data, so given the path to a file, it reads all the pairs inside and returns a plotter.xys, which is a slice of structs xy, which is cool, and an error if something goes wrong. And then finally, plot data is the one that prints, so given the path, that's the path, the output path, so where the PNG file will be created. And the data, the XYS, it does plotting of it, so it creates the file, and then it creates a new plot, does the scatter, and then it computes the linear regression. This is the part where we do the machine learning side of things, and that is the part that we're going to be changing to linear regression, which is here. That what it does is for n iterations, it computes the gradient. And in order to compute the gradient, what it does, it checks for the gradient, for the cost function and its derivatives. And right now, there are two different functions, but actually they compute pretty much the same thing. So we might be able to figure out a way to make them fit into just one so we can make this go a little bit faster. So, okay, so that is all of the code. What I'm going to do first is I'm actually going to divide what is linear regression itself and the rest. So I'm going to create a new package, and that is the package that later on we're going to be modifying to work with linear regression just with Go, and then maybe with Gona, maybe with Gorgonia, might try to TensorFlow later on. So all of these things we're going to be modifying just that linreg, and the main.go should never change. So we should be able to simply move all of this code, so the linear regression down to a file here, linreg.go, package linreg. We're just gonna paste everything there, and I'm gonna call it linear regression. When we save, that's going to take a little bit long. Let's see, Go import was not very happy. Let's try to run it manually, because Go import, when you run it directly from from save, what happens is that it will time out. And sometimes go import takes longer, especially in my machine. My go path is pretty huge, so that's a problem sometimes. So if you run it here on the console, it will disappear. Cool, so we don't have iteration, so we'll need to fix that later. For now, what I'm gonna do is I'm gonna say iterations int. So I'm just gonna pass it as one more parameter. And then here, we're gonna need to do linear regression iterations. Okay, and we're gonna need to also import that package. So I'm gonna do it here. Just for func 39 linreg. Okay, so far everything we've done has been to move the linear regression side of things into a different package and just keep the main package as the main program basically as is. So let's see if this still compiles. And it does, which is cool. Okay, so what's next? What I'm going to do next is try to figure out what's going on with this iteration. Because having a global variable is not necessarily wrong, but it's definitely a code smell. Because what happens if you try to run tests that are modifying or accessing this variable from different places and different Go routines? Do you need maybe mutex in there? Is this a constant? Which kind of is, right? But like, there's a lot of different questions that one might wonder. So what I'm going to do is actually move it to make it so it's always passed around. So that way I will pass iterations here. And what I'm gonna do is I'm actually gonna use the int form that will return a pointer. So then we can do iterations equals this. And we can remove this one here. And this is not happy because plot data now needs one more parameter. That's iterations int. And then that's gonna be using it to call linear regression. Cool, so all of this looks pretty good now. And iterations here is not happy because it expects, we changed the direction. It goes first the XYS, then the iterations. Cool. Okay, so now rather than having a global variable, what we have is just one local flag, and this is something that I really like, having the flags defined directly in the main function. This is something I think was proposed at a talk by Peter Bergen at GopherCon a long time ago, which by the way, I'll be there next week. So if you're around, say hi. But yeah, it's a good idea to avoid having flags as global variables that then it's kind of hard to track. Here you can see exactly where that value is going around, and you know that you cannot access it from anywhere else than the main program because it's not a global variable. So, I think it's a good practice. Okay, the next thing I'm going to do is, so read data returns a plot XYS, which I guess is fine because plot data is going to use that directly. The problem is that then we are passing that to linear regression, and linear regression doesn't necessarily need to know what an XY is. Right now, if you see this dependency on plotter, it is there just because we need this type, right? And it's kind of sad because we don't really need it at all, actually. Instead, what we could do is say we are going to receive XYS. We're going to receive two different values, X and Y's, which are both of type float64. Now, if you do this, basically the dependency on plotter will disappear. And it makes it much easier, in my opinion, to do. It's a nicer way of writing your code because you're not gonna have to have X and Y at the same place, and you don't have extra types that are mysterious. You just have this type here, float64. Okay, so then compute gradient is gonna go also X's and Y's, X's on Y's, and then here we're gonna have float64. Same here. So basically we need to modify a bunch of things, but it's not too hard. Then in here we're gonna have to do, so we could do, you know, just to make sure that everybody is happy, and it's kept more symmetric. That's a word. So it's kept more symmetric. We could do so that's XS. That's gonna iterate over the things, and then we can do, so Y is gonna be Y's of I, and X is gonna be X's of I, and then that's gonna be X's. We're gonna do exact same here. So X's, that's gonna be I. This X, Y of Y is gonna be Y's of I. And the X, which appears twice, is gonna be X's of I. And that's gonna be X's too. Cool, so now with this, we have a package that should work well. So we'll do go install, it should just compile. That's cool. So now the package leanreg does linear regression and does not have any dependencies on anything other than thumped, which probably should be logged, to be honest, but let's leave it as is for now. Okay, so what could we do next? So now, well, that package compiles, but this one, the main program, doesn't anymore, right? Because if we do go install here, it's gonna say, yeah, you said that you were gonna pass X, Y's, and instead you're passing float64, float64. Please change that, which kind of makes sense. So let's do that. So what I'm going to do is, rather than changing how we call linear regression, I'm going to change how we read. So I'm going to do basically same thing as we did before. So X's and Y's is now float64. So we're gonna be calling X's and Y's. And then read data is also going to return X's and Y's. And then this one, so that would be X's and Y's and X's and Y's. This is gonna be nil error. Okay, so now rather than defining this, what we're gonna do is we're gonna have to define two different. So actually X's and Y's are already defined, so we don't need to do much about that. What we need to do is X's equals X's of X, Y's equals append Y's of Y, which is the equivalent of what we were doing before, but now it's in two different slices. If something fails, we still return that. Otherwise, we return X's, Y's, and nil. So this code didn't change much. The most important thing that changed is the fact that now we do not depend on plotter at all, which kind of makes sense because we're reading data, right? You might want to read data for something else than just plotting it. Like for instance, we're doing machine learning from it, so it's important to have it as something as independent from other packages as possible. Okay, so plot data now, this kind of works. This one obviously doesn't work because for new scatter, what we need to pass is an X wire. And now the problem is that, of course, we cannot just simply pass XYS like that. So just in case, let's see, type scatter is this XYS. So sorry. Type XY That's not the one I wanted to see. I wanted to see new scatter. I want to see the one here. So X wire. So let's see what types define this. So X wire. So we have what X values. We have X Y's that satisfies that. So this one, how is this done? XYS, it's just one slice containing the two, and now we have two slices, one each is different. So what we can do is not very complicated, to be honest. It's simply to say we're going to create an X wire of X's and Y's. And now this will complain, obviously, but what we can do is type xwire is a struct that contains x's and y's, which are float 64s. And we can define it like that. And now they still complain, but for a different reason. It's complaining because you are not, in order to satisfy the plotter.xwire, you're missing the len method. So let's see, the len method looks like this. So we're gonna do types xwire. The length is going to return the length of x.xs. And now this will still not compile because now we're missing the xy method. The xy method is pretty similar. So we're just gonna call it the same, xwire. And this is going to return x.xs's of I, x of ys's of I, and then close that. Cool, so with these now, our xwire type satisfies the interface that NeoScatter expects. So that's pretty cool, right? Like we're able to adapt those two slices into what Plotter expects. So that's good. Cool, so this looks pretty good. I wonder if it compiles. Go install. Cool, okay, so let's run it. As before, I'm gonna build it, I'm gonna call it main. When I run main, everything works and the result looks, let's see, good. Okay, so now we've changed a little bit more of the code, but still doing exactly the same. What other things could we change? So read data, opens a file, make sure that it is close at the end, reads the whole thing. Discards data if they're not correct. That looks good. Then plot data. That looks pretty good too. Okay, and let's see on the linear regression side of things. So let's see, linear regression, linreg done, linear regression. Seems a little bit like the name is a little bit repetitive, but I'm gonna leave it as that. It's not a big deal. Now, the thing I'm going to change is this compute gradient and compute cost. You see, every single time we call compute gradient, we print the cost too. And turns out that the gradient and the cost actually look very similar, to the point that this D here, it looks exactly the same on this line, on compute cost and on compute gradients, right? So what I'm going to do is just add one more. So I'm gonna call it cost, DM, and DC. And I'm gonna do cost, it will start by being 0, but we're gonna do cost plus equals D times D. And then we're gonna return cost divided by N. So now basically what we're doing is computing these costs in here. So now we can drop the cost function completely and instead do compute gradient and print cost. And also the last one doesn't really make much sense because anyway, compute cost at the end is gonna print here already. So there's no point in doing it twice. It's gonna print it here as the last line of the loop, exit the loop, and then do it again. There's no point for that, so we can drop it. So let's see, go build, it compiles, it still works perfectly. Okay, so next I'm going to make it so this only prints 10 times. So let's say, how could we do this? So out of the number of iterations, whenever the number of iterations is exactly 1/10 of the number of total iterations, so if 10 times I, no, that's not what I want to do. So I divided by iterations, 10 divided. So modulo iterations equals 0. Then print this. Will that work? Okay, so if that would work, go build. Let's go back to main. Main, it printed only 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 10. Cool. Okay, so I'm pretty sure that was a word count. Yeah, 10 lines. Perfect. So cool. So with this, we already have a program that executes faster a little bit because we are computing this loop only once, and also the program is a little bit smaller, which is cool. And this could be public. Yeah, let's make it public. So we can make this something exported. So gradient and linear regression. We should document this a little bit. Actually, let's document it maybe. Okay, so we're gonna document it real quick. So let's package linreg provides basic implementation of linear regression with gradient descent over on 2-dimensional data. Cool. Linear regression runs the requested number of iterations. Linear regression runs the requested number of iterations, gradient descent, and returns the last the latest approximations, the latest coefficient, the latest approximated coefficients. Cool. And gradient computes the cost function and its gradients. Cool. So this looks now like a pretty decent package. It is super simple, but the cool thing is that then for the next program, what we can do is just simply modify this piece of code, because the rest should just work because it's just using whatever it's using on the other side. So with this, I feel like we're done. So we change a bunch of things. We move the flags to be a local package, local variable on the main function, so you can track where it's going rather than just randomly functions in the main package being able to access it, which is good because then we actually move some of those functions that were in the main package outside, because that way we can prove that basically there's not dependencies on this one, which is cool. Something that I might want to use pretty regularly, building on top of this. So it's good, something separated. Finally, we also made the code a little bit more reusable by removing the dependency on gonam in order to compute the linear regression and the cost. Now, instead, what we are doing is just passing slices of float 64s, which seems like an easier way to get started. Eventually, we might move into multi-dimensional. Rather than 2 dimensions, x and y, we might have x, y, and z, and things like this. And in that case, maybe we'll go back to having some other way of representing this, maybe a slice of slices or something like that to represent the matrix. But for now, this works quite well. So I guess this is the end of the episode 39. Episode 40 is coming up soon. Sorry about the delay. I've been preparing for GopherCon and preparing my talk about machine learning and preparing many things. So it's kind of dramatic that I was not able to release an episode 2 weeks ago, but do not worry, because next episode, I'm going to be recording it right after this one. So in 2 weeks, you'll have a new episode for sure. So, as always, thanks for watching. Please register. Big shout out to all of the people that are supporting me on Patreon, patreon.com/justforfunc, and also to all of those following me on Twitch. I've been doing some live streaming lately, which is fun. I really enjoy it. So you can watch the recordings on YouTube. There's a playlist called Just for Fun Live, I think. So if you go to justforfunc.com, you should see it on the bottom side of the page. Check it out. You might like it. And also maybe follow me on Twitch or on Twitter. On Twitter, I announce every single time there's a new Twitch event coming up. So as always, thanks for watching and see you all in 2 weeks.